Welcome. Thank you for taking your time for this little event. We did quite a few events in the past, but they were always a bit too much marketing to my taste. So I really like this one because without being too technical, we will go in the much more interesting parts for me at least. And yeah, we will give you a tour of the key things that we are doing at Boxalino. Not only me, but especially my two colleagues. But first, we have a theme for the day. And we basically believe that as data enthusiasts, we need to stand for something. And that's not the only thing, but that's one of the things we stand for. So, hopefully for everyone, we have T-shirts to put actions where our mouth is. Yes. And we believe that's true, actually. They really don't. Perfect. Then, now, the agenda for today. So, I will speak myself first about vector search. That's one of the key aspects we have worked on in the last year in our real-time platform. So both for user search and for recommendation. And even if, especially for the speed, it's of a discussable state in terms of being ready to go live. Today is the first time we will show you a demo of our latest product, which is our AI search chat. So you'll be the first one to see what it looks like, except, of course, the internal people. Then Marko will present the dynamic pricing that he has done with reinforcement learning, as well as his work on our advanced KPI dashboards. Ratko himself then will present how we use GenAI for content, the PIM AI classification projects that we have, project creation automation that we do, and finally our product BI with AI, which we hope will be launched in a first version before the end of the year. So these are the topics. Then we have a little Q&A, but then we have an apéro, so we can also discuss freely for a while after if you have any question. But we will take some questions first here in order to discuss them all together. Yeah. So we're pretty excited, and if that's okay with you, we will start to get in directly. Does every one of you has already heard of vector search, or is that a new concept for anyone? Okay, then I go quite quickly on that aspect. Basically, vector search is using what is called text embedding. Here we use different providers like OpenAI and Google in order to get these text embeddings. But in short, what it means is any piece of text, it doesn't matter if it's one word or an entire book, any piece of text can be transformed into a vector. And once we have this vector, then we are able to compare words like cat and kitty and dog, and we're able to identify that cat and kitty are much closer to each other than dog, while all three are much closer to each other than, for instance, a house, meaning that these are all pet animals. Now, this can be used for many things. This is what I'll try to present and even demo a few cases in an e-shop, for instance, for the user to search for something, but also for recommendation. So while this is called vector search, I mean, this is a term which mainly has been established by Google as the standard, but it is really referring more to the technology than the fact of using search. You can use vector search for recommendation. You can use vector search to find similar things. You can use vector search for many different aspects. That's a very powerful system because it allows in real time to identify that a word like kitty is extremely similar to a word like young cats without having a dictionary of synonym, without having any chance to see that with spelling edit distance or anything of that kind. Now, how does that work? Well, the first thing we have to do is we have to integrate in our data platform the capacity to enrich your data with these vectors. The process itself is not necessarily very complex for many things. We receive product data, we receive content data, and through a process using a bit of an NLP to identify what texts are interesting or not, then we are referring and we are calling these external providers like OpenAI, like Google, and we are basically adding for every one of your content, for every one of your product, we're adding that vector, which is telling us basically where this product stands in this vector space. So that's happening at data processing time. This is not, of course, happening in real time. We prepare, we index these things in our real-time platform. But we do that very frequently. That means that if you have a new product and, hello everyone. If you have a new product and you would like to appear in the search in a smart way in the next 10 minutes, then this process will happen in the indexing process of that product right away. So there are some important constraints from that matter for this to happen. Now, this being said, this part of the process is mainly about the indexing. The more complicated part is to actually do this vector search in real time. So what we did is that we extended our real-time index, which we used for a long time for search, for recommendation, for many things, and we integrated the capacity to do real-time vector search in these real-time index. This is actually was not that easy because the time you have in a real-time index to do these distances is actually very small. An e-shop might have several 100,000 products, and search needs to be answered typically 100, maximum 200 milliseconds for complicated cases. So that's a quite important challenge, but once resolved, it opens completely new doors of what's possible to do in real time. So we are able to calculate this distance in real time, which gives us a number, and then we can compare and factor this number in other aspects, like the fact the product is a bestseller, like the fact that the product is a novelty, like the fact that the product has a good click-through rate, and so on and so forth. We can mix this distance with many other factors, with A/B testing as well as represented here, and we can drive the results in real time in your front end. So that's basically how it works behind the scene, so that this capacity is provided. And before I move to what's to come in the next version, I'd just like to take a very simple example here, where on Lehneversand, which is a website that only delivers results in French and in German, thanks to vector search, is searched like Swiss trad clothes. So I like this example because it's quite obvious that they will not spend a single second to optimize searches like this. It's in the wrong language, and it's using abbreviations which are common for Americans and that people would not use here at all. But with vector search, it doesn't matter at all. Doesn't matter at all. That's what we get out of the box. None of the keywords are in here in the title yet. That's exactly what the system shows. And it does that in real time, 100 to 200 milliseconds max, including the round trip to OpenAI to get the embedding, because of course the system needs to do that in real time for the simple reason that so far no one else had the weird idea to make that specific search. So that's a very, very important thing, and that's been something we have released on now all of our e-commerce customers. We have done a lot of A/B testing, and what we realized is that this was really good to solve a lot of the cases that were making the management unhappy when they say, oh, if I search for this, I have no result. Well, now you don't. Now you have meaningful results. Now, this basically had a big effect on 10 to 15% of the searches. So that's good to take because these searches actually have a good conversion rate when the results are the right one. But it's not the majority of the cases because the majority of people type 1 or 2 words, very common words, typically very precise words that are that could be found in the data. So what we were basically trying to do is to say, well, how can we use the benefits of AI search since the first letter people type? And that's a problem because if we take the example of a website like Perfect Hair selling a lot of beauty product, when someone types Kera, and I take this example like K-E-R-A, it's not finished typing, but our search has to provide things while they're typing. So when they're typing for Kera, which happens many hundreds of times per day, so not like the case I showed you, that's a very, very common case. Well, what can a vector search do? Well, nothing good, because a vector search is not a prefix match. So the vector search will just say, well, here's Kera, well, I guess it's a name, I don't know, and well, just show you stuff. So that's a net negative. If you just take what the user type and you use it to create vector search results, you can say you're using AI and look good, but actually you're doing something worse than a prefix match with a keyword search. So that's a problem. Now, how can we solve it? And basically, the idea is that you can use the statistics, you can use the wisdom of the crowd, you can use the information of when people search for something that starts with Kera. What do they end up typing? What do they end up clicking? What do they end up buying? And then you can expand this. And then we get into a fantastic property, which, to be frank with you, when I realized how well it works, I couldn't believe it. The fact that you can aggregate these vectors, you can average these vectors into a composite vector, and it works. So you can take something like kerastase and keratin, as well as all of the other related topics that people search, and say, this is what people mean. We know it. This is what people mean when they start their search by these 4 letters. That's what they mean. Let's take the average embedding of this, and the next time someone starts by typing K-E-R-A, let's use that vector instead of the Kera embedding vector, which means that we will be able to predict and do AI vector search based on the prediction of what they mean in a way which is, from a technical perspective, actually pretty straightforward. So that's something which is very exciting. We're doing all the things which are related to keyword match, because the problem is that you cannot use a vector search alone in a eShop. Vector search is super good to be smart and broad, but actually pretty fuzzy, which is not always what you want when the user is typing something very precise, like a specific product name or a specific identifier or something of that kind. So we have to do a mix between keyword and vector. That's, well, actually made our life much more difficult, but we realized quickly we had to. And now we also integrate cutoff to say, well, we have keyword matches, but these keyword matches are basically not so good. So if the embedding distance, if the vector distance is too big, then let's take them out. So that also will be a nice added feature. But the big novelty will be on the prediction. So that's for how we can use real-time vector search for the case of search. But it's in no way the only case we can use it for. We can use it for connecting anything with anything. We can connect for similarities or relationship or related themes. So when I'm looking at an article, a blog article, or a landing page which is about feeding the kittens, well, this blog article itself has an embedding, and we don't need this article to have any tags, any categories that are the same as the products. We simply don't, because we can simply say, hey, let's take the embedding of that content and let's show the recommendation of the products which are very near this embedding. So in the case of search, we are connecting what people type to products or content, but we can use the same method to connect any content to any product to any product, any product, any content to any content. So that basically makes similarity, related topics, related things out of the box, more or less for everything. That's for the recommendation, but it doesn't stop there. You can go a step further and you can use it for personalization. So you can say, well, let's look everything the customer did, the product that they bought, the searches that they did. And exactly in the same way I explained before, we can take the embedding of all of these actions and do exactly the same. Take the average. Now, you might want to take a weighted average because you want to put more focus on what they bought or on what they did recently. You can do different versions, different variants of these vectors. But then we're in a different world, because then it's not that the product has a vector, it's not that the text as a vector, it's that the customer is a vector. So that's a very interesting idea, because then you can say, well, let's take the vector representing the customer and define if the product of my newsletter are relevant for him or not, and then decide to send it or not. Let's decide whether this customer should be considered for being informed of these new products that I would like to launch, and so on and so forth. You introduce the concept that the customer himself is a vector. Believe me, Google didn't wait to figure that one out, and that's exactly what they do to you when you use YouTube. You are the vector. Every click you do, every video you look, updates not their vector, you as a vector. And then they use that vector to identify what's coming next. It's the same idea, but there we can use it in any activities, in any type of marketing planning. Now, let's get to the last case with vector search. Then I have actually something else to say, because vector search, basically, this is what all of my customers start to be tired, because every time I have a meeting with them, basically at least 40, 50, 60% of the time, that's what I speak about, because we use it for everything. But I think it's a good reason. It's actually something that is good to be used for everything. I have actually something else than vector search to show after. But as the last case of vector search, this is A/B test that a new algorithm that we have A/B tested recently with Lenovo's. It is the first time ever that we have an A/B test which exceeded the 1 million additional yearly turnover. Now, what does this algorithm does? It's a similar idea, but it goes a bit step further. So we take the product that you are putting to your basket, and we consider the fact that many of these products don't have a lot of cross-selling data, the wisdom of the crowd, what people buy together with that product. Your top sellers, it's okay, because a lot of people buy them with something else, so we can recommend something. But for most of the product, for what we call the long tail products, that is not the case. Now, how can you define a cross-selling, so a recommendation of something that goes well with it, if you have no idea of what people buy with this product? Well, Again, broken record, you can use vector search. How do you do that? Well, you can say, well, what are the products that are the most similar to these long tail products which do have statistics? So you propagate, not to one, but to a collection of them. So you find the nearest products on which the wisdom of the crowd, on which what people buy together is actually known. And then you propagate and you take all of the products that are often bought together, and that gives you kind of a map. And this map represents the type of product that is a good cross-selling target for that product, even if that product has never been sold so far. That's maybe a new product you never sold. Doesn't matter, because it is similar to others you did sell, and through this aggregation, we are able to do that. Now, do we want to recommend these specific products that are often bought together with the similar products? No, we want to do better, because maybe there is a new product that has also never been sold. And maybe you want to push it. It's definitely not part of these products. So what can we do? Same trick out of the same hat. We take the average on betting of all of these representative cross-selling products, and that's what we recommend. And we say, and that means that there, it's not that the search is the vector, it's not that the content of the product is the vector, it's not that you are the vector, deal with it, you are still the vector, but that's another topic. It's that the representation of what is a good cross-selling for that product is a vector. And then you can mix it with whatever you want. You can say, okay, I'm going to recommend products that are new, that have a good margin, that are near this target vector. And as a result, you can have a relevant cross-selling recommendation, leveraging the wisdom of the crowd, showing for products that have never been sold before, relevant recommendation of products that have never been sold before. Now, for the last part, we have developed a AI search chat. Now, we know chatbots can be used for many different things. There is one area that we know very well, which is how people search. Boxalino is delivering e-commerce shop search for over 15 years. So that's something we know very well, what works, what doesn't work. And regardless of how cool it is what we can do with vector search, we're not solving every problem with vector search, even with the next version that we will do with the prediction. Because for a lot of cases, what people are typing can match many different things. If I go on Perfector and I search for shampoo, and they have 3,000 shampoo, and I don't know which one to select, the vector search will not magically help me. Now, how do we typically solve that problem? Well, we solve that problem by trying to show filtering options, to try to help people refine their queries, and so on and so forth. This is a game which we play for a long time. This is a game we are helping a lot, but this is a game we are more and more and more losing on the mobile. Because the usage of these filters is too difficult, too many clicks, too many things to do. You have to open a filter panel and so on and so forth. Now, we try to solve it by suggesting the best filter, a little bit like Galaxus is doing. We try to solve it the best we can, but the reality is that we're just scratching the surface. That's where AI search chat brings another idea, another dimension. So here, the search here for headphone, which is fine. There's no problem with the search. It's just there are hundreds of products. This can be then transferred to the AI chat, and then it's the chat which takes this starting point, too many possibilities, and brings it to completion. So now, what I have done is that I have secured my position, because in case we have problems with the demo, because it's really, really new, I have done a video of the demo, so we will try with the normal way. And I already announced we have a significant, it's not a significant, but we have an issue which looks significant, that there is a problem of delay. But that, of course, is going to be resolved very, very soon. But sure. But we're going to try. Just let's see how it goes. So, to explain the context. So, the context, if we take the case of Geschenke Day, and I want to give a gift for my wife, and I look at different things, and I'm like, okay, maybe it's a wellness Geschenk set. I can search for that. Maybe something for the Wochenende. I can search for that. Here there's 260 things I can do in the Wochenende. There is endless product about wellness of different kind. I mean, if I search here for wellness, you can see that there is 131 weekend, Gutschein hotel. There is too much. I don't know how to do that. So what I can do is to basically, that's my starting point. So we take search as the starting point. So here we basically have that situation. And I need to have this open. Then I say, no, I would like, my German is discussable, to say the least. But then I say, no, thank you for these suggestions for the wellness, but it's not really what I want. I'd like to have something like more special. I would like to have something which is maybe something more like a weekend that we can do together with my wife. That's what I typed, and this is what the system then showed. Now, what's interesting is that when you type this and you have these results, then by seeing the result, and that's very important, by seeing the results, I realize what these results match or don't match in what is a good fit. It's actually much harder to just answer to an abstract question. So now that I see this, I can say, no, these are fine, but do you have something, not no, but these are fine, but do you have something more like for the mountain, because my wife is a mountain person. And that's much more, can you imagine, like you make a search, you see these results, maybe you get to that point, and then you realize that basically there is something which is, it's not that it's wrong, it's not that it didn't do what you ask, but there is kind of a mismatch with, now that you see the results. And then basically you can see the results below. So, sorry for the demo effect with the chat. To be frank, that was a little bit the problem when we try to show things that are just on the first version. But I hope that was still helpful to understand the idea. And I thank you very much for your attention, and I will give the voice to Marko.
Right, so good afternoon, everybody, and welcome once again. To get a formal introduction, my name is Marko Tankosic. I'm a senior data scientist here at Boxalino. My previous experiences involve algorithmical trading. I worked for large investment funds. I also do analytics, behavioral analytics, and classical statistics, and I specialize in behavioral analytics and reinforcement learning. Now, to get these concepts a bit closer to you, what reinforcement learning actually does. In contrast to conventional machine learning techniques, which learn from predefined data, reinforcement learning learns from experimentation and exploration. What does it mean in terms? So we create what is essentially an AI agent that mimics either human or any other form of patented behavior. These agents are goal-oriented, which means they are given a task to perform and a reward function. Essentially, what this means is that any agent will take an action, you assert what is the quality of that action, and you provide the agent with the reward. The better the agent performs, the better reward he will get, the more his learning curve will go towards that pattern or that set of actions. So what I essentially specialize is in mimicking human behavior on a level of what is essentially superintelligence. In terms of projects that we are working on in Boxalino, there is only two for me: dynamic pricing and advanced business KPIs. Dynamic pricing is a form of an optimization of your product pricing and your product strategy. While KPIs, we try to essentially start with the basic KPIs and move into advanced level until we reach action. So in terms of dynamic pricing, Occam's razor, the simplest solution usually works the best. So what we try to solve with this problem is that for our customers that have their prices constantly changing and the prices of competition constantly changing, we create agents that mimic the user's behavior and then run simulations that try to determine at what price at that time, based on historical data and benchmarks, what is the most optimized price or the best price that the user will actually pay for this specific product. How do we do this? We created 4 reinforcement learning agents. These agents have the same reward, and that reward can be optimized to perform any task. To maximize your profits, to maximize the amount of sales, to optimize any other aspect of your business, which is in terms of pricing. Now, the difference between these 4 agents, or rather the only difference, is how they choose to run their simulation and how they choose to pick a price to test. Now, in one particular case, for one particular client, these agents are all optimized to do a single thing: increase the profits. So these agents run a simulation. Each of them runs 1,000 iterations of this every day. And based on that simulations, they recommend to a user some price. Each day, this process continues and the agent learns more, it discovers more patterns, it explores more, and each day it tracks the changes in the prices and what it recommends to you. So essentially how this looks in sort of a practice is you get this lovely little table that contains all of the pricing for your dates and the tracking of the price changes. It takes into account, in this specific case, a Google merchant price, but it is not limited to a single benchmark. So you can use your own margins, you can use your competitor prices. And each day, these 4 algorithms recommend a certain price. Now, in the case that's been shown here, the 2 of the 4 algorithms converge on the same price. Sometimes all 4 algorithms will converge on the same price, or based on what they are provided as targets, they may provide you with a totally different price. So you can have one agent focusing on profits, another agent focusing on revenue, and they will give you a different recommendation of the price. In other cases, most of the agents will convert on a single price, and that is the price that through voting system is, essentially speaking, recommended to the users. That is about it for dynamic pricing. The next project is business KPI dashboards. Now, what is the actual goal with this project? We call it the KPI dashboards, but essentially is the system of analyzing and assigning action to your business. How do we do this? We still use machine learning trends. We use statistical calculations to recalculate your KPIs in such a way that they derive actions and they derive deep insights with the focus on that action. The dashboard itself, it's focused on simplicity, interactability, and actions. What do we mean by that? So this is how the process usually works. You have a bunch of data from your sales or any other form of tracked observations in data, and some crafty data scientist or a BI expert turns this data into an information, and the result is this. Now, among you, I see a few of my colleagues who are data scientists who can tell you that we call this visualization and information clutter. A lot of information presented to you with no context, no meaning, no insights derived from this data. The biggest part or the biggest effort of your business in this regard is your insights derived from this data. So it's you who have to look at all these charts, look at all these numbers, compare them, derive meaning and insights from them in order to take certain actions. When we say actions, this can be anything. You see that your revenue is falling, try to send a promotion or sale. You see that the product is performing poorly, remove the product from the website or anything like that. So Boxalino's solution to this is to create a set of visualizations and a dashboard that can give you some information at a glance to nullify the clutter in visualization and your general information overload, and to derive a form of actions and a timing for that actions. So instead of all of your analysts and business people doing countless hours of work, putting effort into interpreting the visualizations and the data, this system does that for you. And it's designed to work in synergy with BI with AI, which is something my colleague will present to you. But essentially speaking, if the dashboard will tell you when to perform an action, BI with AI will tell you why that action is required. So in terms of how this looks, and I must apologize, this is actually real data from an actual client of Boxalino. But what do we mean in terms of interactivity and simplicity? So these sort of visualizations are designed to give you informations at a glance. So you don't spend much time searching for what you need. This is just your contributions in terms of profit, in terms of quantities, or in terms of number of orders. Another form of visualization that we use, and some of you will know this as a tree map, also uses color and size to provide you information at a glance. What of your, in this case, brands and categories within those brands are contributing most to, in this case, your profits? These are interactable, clear, simple visualizations. Now, there is also opportunity to show you some details. For instance, for some products, you can have a detailed page. And on that detailed page, you can see the total revenue, you can see the profits, you can see the total sales, but you can see how your purchase and selling price have evolved over time and what is the percent change over that time, once again, at a glance. You can do a categorical analysis. In this case, these are brands. It takes a bit. So you can see the contributions of all of your brands, but you can see some statistical analysis in terms of how your brands perform month to month or how they perform year to year. Now, what we mean when we say in terms of interactability, so at a single click of a button, you can change the perspective you're looking at this. One side can be profits and another side can be revenue or sales. This is for each client tailor-made. But you can also see how your customer retention rate, for instance, per brand is moving over month and what is the percent change. All of these things that I've just shown you are not the terminal goal of this project. These are all instrumental goals. Terminal goal is to arrive at this. This is a simple action report. For any given day, for each day, it will give you a set of actions that you actually need to perform. Or it will give you some relevant information about your products or your brands or anything you customize this system to work with. This is the point. This is the terminal goal. This is what we want to achieve. All of this is just to present to you a justification of what in your data has triggered some agent or some AI system to perform this action, to recommend this action to you. So it will give you, and this is going to be a bit difficult to zoom in now. But so even for a given period, it will analyze trends, patterns in your data, repeated things that are happening, and it can suggest different actions. So it will see a downward slope and it will tell you to send an email, send promotion, or it will tell you that your inventory stocks are low, but your demand for the certain product or a certain category of product is on the rise. So it will recommend or inform you of the action. Again, these systems is designed with removing all the needs for you to do lengthy analysis while you have people already capable and a system already capable of doing that at the superhuman level. That is what we are trying to achieve with this. And again, this is utterly all customizable to your needs. There is nothing in essence that we cannot tailor to your explicit business or to use some common statistic. That is all for me. Thank you very much for listening. Appreciate it.
All right, so hi everybody. I think I know some of you, but for those of you who I don't know, I'm Ratko Nikolić. I have been a senior data scientist in Boxalino for the past 6 months, during which I have mostly focused on projects involving generative artificial intelligence, and more specifically, large language models. My previous experience in data science includes various fields and industries, ranging from research, marketing, automation of media monitoring, supply chain optimization, as well as lately also the LLM-based systems that my projects were mostly about during the past 6 months. So since all of my projects were in one way or another based on LLMs, I thought of saying a couple of words about technology, although I am quite certain that you could not have escaped them in the media or in your life for the past 3 years. So what LLMs represent is basically a relatively new class of AI capable of processing, analyzing, and generating textual, and as of recently, also multimodal data, including audio, video, and images. So although they have been developed for quite some time, they have entered the mainstream mainly during the past 3 years since the launch of ChatGPT, that chatbot that we all know and love and use it for all, like many different purposes. Since then, the applications of LLMs have exploded ever since and across different industry. And now they're using from automated customer support over helping software developers write quicker and better code, all the way up to teaching math and generating all kinds of contents, ranging from SEO content, poetry, novels, and even your kids' homework essay, which some teachers apparently do not approve of. And currently, as all of the big tech players and then some have recognized the potential and the value they can bring, there is a large number of different LLMs offered on the market, starting from the most known OpenAI's offering, including the GPT-4o and o1, also known as a Strawberry, over Google's Gemini, Meta's Llama, Anthropic's Claude 3.5 Sonnet. There are basically many of them on the market. And truth be told, not all of them are equally capable or equally useful for a particular task. And it could also be said that you cannot really rank them by one factor, because if a particular LLM excels at a certain task, it doesn't really mean that it will be the best across all of the tasks they can perform. And therefore, in Boxalino, we decided not to get married to any particular family of the models, but just stick to applying the one that makes the most sense in a context and that brings the most value to our customers. And this is the philosophy that we stick to across all of the projects involving LLMs that we have. So the idea for today is to say a couple of words about these 4 main projects that I've worked over the past 6 months, and that include Gen AI content generation, basically a project that we've worked on with Lennart Versand and Perfect Hair. PIM classification, a project that we've done specifically with Lennart Versand. Renovation project description automation that we've done with Renovero. Guys from Renovero are here, so thank you very much for visiting. And finally, say a couple of words about BI and AI, BI with AI, which is, I would say, the project I was really most excited about, and hopefully you will be as well. So without further ado, let's say a couple of words about the Gen AI content creation. So the goal here is pretty clear. We wanted to automate as much of the content creation workflow as we can. And according to our estimates, that is even up to 95% of it. So including text, images, and video generation. For different clients, we focused on different things. So for Lennart Versand, we mostly focused on automating SEO writing, as well as creating customized product descriptions. While for Perfect Hair, we were a bit more ambitious, and we wanted to cover the whole process. So basically from campaign planning, over putting it in action, over deciding exactly what individual content pieces need to be created in order to, put the campaign into action. So basically, although the automation is our final goal down the line, the philosophy that we stick to for each and every of these projects is that a user really should be under full control of the system at all times. So we are using AppSheet, and if you don't know, you can think of it as a sort of an Excel, user-friendly way to communicate directly with the AI, using which the user can evaluate, edit, validate for publication, or even if they deem that the LLM has misperformed very badly, mark certain piece of content for regeneration. I mean, of course, down the line, the idea is to improve the system up to the point where user control is largely unnecessary, but this will always, of course, remain a viable option. This is a work in progress, of course, in both cases. And our focus so far has mainly been on automating the textual aspect of the content generation, but we are adding new features as we go, and we are also working on like including the capability to also generate images and videos as well. To shortly describe how it all looks underneath the hood, so basically we start with the client's media server or client's Jira. And there we find all of those typical documents that your human marketing team encounters when they start thinking about the campaign. Sort of like the campaign briefs, the supplier guidelines on what kind of content you need to create, the product description, some notes from the meeting you had with your creative team the other week. And what we do is we ask the LLM to take this massive amount of unstructured data in all shapes and forms and extract the information from it, packing it into our campaign master table. And the campaign master table is the place where the information is structured and when it's packed into its campaign templates that define what the campaign is about, who it's communicating to, what kind of content should be created, and when it should be published. So from then, individual content types are recognized and put into the content entry table, from where the LLM easily picks each one of them, generates all of the content elements that are needed, and returns them into the content entry table, where your human experts review the content if needed, change it, and either validate it for production or ask for a retry. This is, of course, not the only point where the human is in control of the system, and that this can happen everywhere pretty much where the app sheet icon is present here. So, in order not to speak about the app sheet too abstractly, let's see how it really looks in reality. So, this is an example of the content entry table that I have mentioned. Here we can see that this is a bunch of topics that were created for Perfect Hair. And I guess it's worth saying a couple of words about what topic page... no, actually I'll do that for the front, sorry. Basically these are a couple of examples of content created for Perfect Hair. These are topic pages. And in this overview, what we can see is what content type it is about, some information about campaign planning, some parameters that the LLM uses in order to generate the content, as well as the final elements that were generated. Now, this doesn't show us much, but for example, if we click on pedicure, we will see the detailed view, and here we can see much better all of the elements. Now, when a human admin engages with this, what they can do, I mean, if they find that everything is completely fine, they can just validate it. However, they can also go into detail and evaluate each and every piece of content that was created. If they don't like something, they can simply edit it and then validate it. Or otherwise, if they really think that the whole thing should be regenerated altogether, they can also leave some additional instructions in order to point the LLM in the way in which they want to see changes. And then, just send it for regeneration. So, the next project I'd like to say a couple of words about is PIM classification. This is a project that we've primarily done for Länder for a very particular purpose of helping them migrate their current PIM system to a new PIM system that is like a product information management system, as well as automating its subsequent maintenance. Anyone who's ever had the beautiful task of manually searching for product attribute information basically knows it's a major pain in the butt. You have to read boring product manuals and supplier information and even Google for hours to try to find some very obscure attribute about your product. And the worst thing is that sometimes you won't even manage to do it. And at the same time, you might ask yourself, why bother? Well, because it's very important to know what the attributes of our products are. It's a sort of a foundation for all of the other systems that we've spoken about. So this project basically addresses that pain. And what it does, it relies on this capability of the LLM to extract massive amounts to extract attribute information from massive amounts of unstructured textual or visual data. including product descriptions, PDFs, Word documents, as well as pictures, as we will see shortly. If all else fails and you don't find the product information that you're searching for, the system is also capable of crawling and scraping the information off the internet. So the idea, having seen how the process looks like in practice when a human does it, it's our estimate that we can reduce the time and effort needed to process a single product by a factor of more than 10. And when I say that, I basically mean that down the line, a human will only be there to evaluate and validate the results of the system. Of course, as with any other LLM system that we have, the system is also under full control of the human, who can evaluate, edit, and regenerate the system's outputs any way they see fit. Also, key thing here is to mention that the system is designed to learn from human feedback. So once it does get some information about what needs to be changed, it will include it into the way it's reasoning about the next batch, and you can expect that batch over batch the system will be improving on its own. How it works is, I would say, much more straightforward than the previous diagram. So we first map and gather all of the information that we need for the attribute classification to happen. So from the old PIM system, we take product information. We gather all of the additional product documentation, supplier documentation, the stuff from the internet, whatever we need. And very importantly, we get the target classification schema. So basically, all these new attributes that, for which values need to be assigned for every product, and of course, internet, which I mentioned. And once we've gathered them, we basically just tell the LLM to extract the information, analyze it, and assign all of the attribute values. Once that happens, the results are written into the validation admin, the app sheets that we've seen, and humans either decide to change it and validate it, or they say that they want to regenerate it altogether. If they decide to validate it, the information is written into the new PIM, and at the same time, the feedback is basically inserted back into the LLM so that it knows how not to repeat its mistakes in the future. Just a short demonstration of how the app sheet looks like. So not much new to see here. Instead of generated content, we can see products belonging to the Oberbekleidung product category. I think it's a subcategory of the 11, which means workwear. And what is special about this particular batch of products is that for them, we did not primarily rely on the product descriptions, but also on the supplier PDFs that we received as well. So if we click on one of them, for example, the Helly Hansen Pilotenjacke from Bergholm, we'll see that it's quite a generous product description, and that we can extract many attributes from it, as we can see here. However, there is an attribute, this Pflegehinweise, like the care attribute, that really is nowhere to be found here. So if we also include this PDF, we will see that the LLM is quite capable, with no additional instruction, of taking these images from the corner of the PDF and turning them into valuable information. So going back to the presentation, let's talk a bit about the project we are currently working on with Renovero, which you guys being Swiss, you probably know much more about it than I do, apart from the experience that I have during this project. But the core idea here is that it's a platform that serves as an intermediary between people who have certain needs of a renovation project in their homes on one side, and the craftspeople who are willing and capable of fulfilling such projects. And what we had the problem there was that the existing basically project creation process, what the procedure the users that would have to go through in order to create the project, was a bit too complicated, involved, I would say, a lot of complicated choices, writing a lot of questions, as well as a relatively outdated project category tree that grew over time and was, just increasing the frustration of a user who wanted to just leave a simple project there. So in cooperation with some of the guys you can see in the audience, we decided to see how we can replace this project category 3. And we took like the last 5 years of the project descriptions that were posted on the website and that had received an offer, so the successful ones, you can say it, and we embedded each one of them using OpenAI's embedding, in a sense creating a vector out of each of the textual descriptions. And then we use those vectors for a hierarchical clustering approach to see how the algorithm would naturally group these product descriptions, without relying on this old and outdated category tree. For each cluster that we found this way, we asked the LLM to generate a sort of a question template designed specifically to extract all of the information needed by the craftsperson in order to make a meaningful offer. So the point of the project was, on one side, to reduce the frustration that the users had while creating a project, and therefore the attrition rate. And on the other side, to make sure that the people on the other side, the craftspeople, actually received all of the information they needed in order to make an offer. We are yet to go live, so we'll see how it how it will perform in practice, but we're very optimistic about it. If we look at the diagram of how it's working, well, I pretty much covered this part. So we begin with the historical project descriptions, where the hierarchical clustering algorithm is used to find the natural grouping of the projects. Then for each of the product clusters, we ask the LLM to create a question template, which results in this project template database. And now, instead of zigzagging between these two squares, I think it's best to basically show how a project creation looks in practice, and hope we will not have the same fate as with the previous ones. Okay, so my German is tragic, so please help me if I write something stupid, but I want to, for example, renovate my kitchen, and I want an overall kitchen renovation. So I start writing Küche. And even before I'm done, the vector search takes over and shows me all of the relevant, utilizing this wisdom of the crowd approach, shows me all of the relevant clusters that I might need. And before even finishing the word, I know that this is the one I want to select. And once I do that, there are no complicated choices and no essay questions. All I need to do is answer these 10 simple questions, and I'm ready to go. So let's start. I want a new kitchen installed. I am in the planning phase. It's about 10 meters squared in surface. I am going to need the floor, the electric work, the devices, as well as the cabinets. Only premium for my kitchen. I want the Arbeitsplatte to be out of granite. The cabinet should be out of wood. I want special lighting. It's very important for me, and I don't have the materials, and the worker that accepts this project should bring them. Naturally, I will give all of the money I have for my kitchen, and when I click this, here it is. A concise but information-rich description that the craftsperson just need a very short information to see and evaluate whether they are the kind of person that should offer this project. So, the idea is to make the process a lot more enjoyable, and so that it requires a lot less time and effort, and I think this will pretty much do it. Okay. So let's move on. Let's go back to the BI with AI, which is, I would say, the hottest new thing, but that's probably because I'm building it. So the idea here, in a nutshell, is to create a data analyst that doesn't have to sleep or eat, that you can bug 24/7 with all kinds of requests and questions about how your business is performing and what should be done to improve it, with no risk of them reporting you to the HR person. in a more technical terms, it's actually a system that combines powerful LLM agentic capabilities on one side with decades of e-commerce domain knowledge on the other side, in order to allow for basically automating the execution of complex data analysis tasks, automating BI reporting, as well as answering data-related user questions in real time. Imagine a ChatGPT on steroids that is intimately knows your business and the data related to its day-to-day operations. So, using a simple chat interface, a user can ask complex business and data-related questions and get the immediate answer, whether it's about sales trends, customer behavior, or other business-critical insights, making all of this analysis accessible to everyone regardless of their technical expertise. As I mentioned, at the core of the system is a powerful LLM agent, which is further empowered first with the up-to-date data of the user's business, as well as global macroeconomic trends, specific trends within the Swiss e-commerce sector, and expert domain knowledge of the field. It is a work in progress, and we are adding features to it regularly, but the end goal is to make it capable of not only answering your data-related questions, but also being able, in synergy with what the system that Marko is building, of giving you preemptive warnings as well as the strategical business advice, sort of being the why counterpart of the system that Marko is building. How it works, on this diagram, we can see that basically we start from here, so the time has come either to create a weekly PPT report, or to make a video for the CEO, or you simply want to ask your chatbot a question about your business. So how is my revenue performing? Is that Google campaign that we've started paying, is it making sense? Stuff like that. So first what happens is that LLM takes the user's requests, and then using the code interpreter, which is an out-of-the-box thing that comes with in this case, OpenAI's GPT, then it translates these questions into Python code. So basically the code that executes this data analysis tasks, and the LLM executes them themselves. And then the results are basically turned into narrative, and then they're either served as an answer to the user, in this case, or as a sort of an automated PPT creation template that the user can then edit, and that Sylvain will explain in further detail. Or finally, in the form of a video, a sort of a news report about your own business that you can listen to and get all the information you need. There are certain class of questions that are relatively straightforward to translate from business requirements into the code and then into the insights. However, there are those who are a bit more complicated and that really require either specific domain knowledge or application of more advanced algorithms like machine learning algorithms. And where we are is that we are mapping those areas where additional guided reasoning is required to make the LLM work for basically all of the requirements you have, and then tackling one by one. So, for example, there is a question of what were my key revenue drivers for past month? And it's not a straightforward question. It really depends on the context, and it really depends on a experienced data analyst on basically operationalizing that question into things that can be measured with statistics. So we basically created a function and additional resources, for example, that you can use. So in this particular case, it makes an XGBoost, which is a machine learning model of the revenue for the past month and for the reference period, which may be 6 months or a year, extracts feature importance out of both of those, and then basically looks at which features have gained the most importance during the last month in comparison to the reference period, in order to basically give you inspiration on where you should place your focus next. So without further ado, I think that it's time for Sylvain to basically demonstrate how it works in practice. Thank you.
Okay. So here we're showing basically the case where the BI with AI generates a presentation. And the goal of the BI with AI is really to replace as much as possible, or at least to reduce a lot, the work of a data analyst. And so, as Ratko explained before, then the LLM is actually able to generate all of the information that are required to do that, and the output will be here presented in the template of the company with the logic of the slide the company wants in a Google slide. And that's very important because not only do we have the information here, for instance, about the evolution of the revenue compared to the prior year, we have also our benchmark, which is on top of it, and we have here the analysis and the interpretation of the LLM about these data. But this is all in editable form. That means that I can, as a data analyst, say, yeah, that's fine, but I think we have to basically change the color because our business is really doing horribly, and I'd like to emphasize this. And he can go in under the elements in an editable way. So it's not because it's generated by the AI that is in any shape or form different from something he would have done himself in preparing the presentation. And here I can go in the edition of the chart, I can customize the series, and I can say, in the case of this one, where is the color here? I would like to basically emphasize a bit that we're not doing very well. Then I go back here and I can modify this. And this is basically all in editable form. The BI with AI can create 50 slides, out of which you select 12, tune them, present them. So it's a massive advantage in regard of the work that a data analyst typically has to do in order to prepare this presentation. In particular, we have these 3 slides where basically the system is showing the result of generated machine learning Python code using XGBoost, I think, in order to define from all of the possible metrics, all of the data points, what are the ones that are the most important for the business managers to look at. The revenue is going down, but the returning customer is actually extremely stable. The percentage of the active returning customer is even a little bit going up. I don't need an analyst to look at the data to understand, not just to prepare the data, but to understand I have a problem with new customer acquisition. Because if my new customer, my active customer, returning customer is staying very good, but my revenue is dropping, that means I'm losing revenue from the other side. So these are things which are now fully automated. The advantage of having them on a PowerPoint is that you can edit the presentation, add your own comments. Maybe sometimes you don't agree with the interpretation of the LLM. You will just change a few words or adjust something, anything like this, and then you present it to your boss. But there's also the case where we want to have an immediate information that is sent to us automatically, and what is the best way to consume it than directly in a video.
Hello and welcome to a new monthly video of the Early Adopter Program, BI with AI from the Winning Interactions platform of Boxalino. The evolution of the revenue of your shop year to date is minus 8.64%. The revenue for 2024 is closely aligned with the 2023 performance from January to August, slightly underperforming in July and August compared to both the 2023 values and the benchmark, while the projections for September to December remain to be seen. Channels: direct dominates, organic search steady, paid search drops mid-2024. Regions: Zürich leads with slight decline mid-2024. Other stable: device. Mobile leads over 55%, desktop around 40%, slight rise mid-2024. Brand 1 and Brand 4 show moderate declines, while Brand 2 and Brand 6 have significant drops. Brand 3 shows growth, with other brands mostly declining. Orders and revenue are both below the benchmark for 2024, with web orders showing a slight decline compared to 2023. Own web AOV has slightly declined in 2024 compared to 2023, while revenue remains below the benchmark. Own web new customers have decreased slightly in 2024, with both new customers and revenue below the benchmark. AOV, AOM, and customer metrics for 2024 are generally below both the 2023 levels and the benchmark across all segments, with price per unit being an exception, showing improvement toward the end of the year. I have analyzed your data using advanced data science and machine learning techniques, and I have identified 3 drivers of change for you to consider. The smaller change in product returning customers compared to the larger decline in own web revenue suggests that while customer retention remains stable, other factors like lower purchase frequency, order value, or external competition may be driving the revenue drop. The discrepancy between the stable returning customer percentage and the declining web revenue suggests that despite retaining a consistent share of customers, the revenue per customer or overall sales volume is dropping, pointing to issues beyond customer retention, such as lower spend or fewer transactions per customer. The divergence between stable units per transaction and declining web revenue indicates that while the number of items per purchase remains consistent, other factors like lower pricing or fewer overall transactions are driving the revenue decrease. The drop in SEO traffic for key competitors, especially the leader, suggests a potential opportunity to capture market share, while the steady or rising traffic for other competitors highlight the need to remain competitive in organic search rankings. The varying newsletter activity among competitors, with some increasing and others reducing their efforts, highlights different strategies, suggesting a potential competitive advantage for those maintaining higher engagement through frequent communication. Thank you for your attention, and see you soon for another BI with AI from the Winning Interactions platform of Boxalino.
That's it. No more work to do to create a PowerPoint or inform the managers about the evolution of the figures. Wouldn't that be nice? Okay, so the idea was to basically use about 2 hours for the presentation and Q&A. So we basically still have a bit over 20 minutes. Then we will have the apéro, and as long as you don't weirdly think that you heard us enough, then you're welcome to stay and interact with us even more. Do you mind if I just say a few words? Because that's for me a case I also really like. So it would be sad, just because Ratko, did it very well, but just to show it visually, this is a very important case for me as well, because the idea is that these pages are automatically generated, 100% automatically generated. Like, no one is saying it should be toaster. No one is saying, okay, I agree, the picture, fine, but that will come. The text is automatically generated. These related categories, which are critical not only for the navigation, but for the linking of the page, because SEO is as much about text as it's about linkages between the pages, are also done automatically with my favorite same trick, of course, vector search. Of course, the results are generated by Boxalino vector search algorithms, so they're all automatic, and all of the basically texts that are appearing here are all generated by the LM of Ratko, including the links that are appearing within these texts. And that means that this is something which will cover all of the SEO holes of the company automatically. We look at the SEMrush data. We look at which keywords competitors are doing better. Most of the time, not always, but most of the time, for the cases where you have products, the problem is a missing landing page, most of the time. A landing page which is too broad, like all of the kitchen appliances, there's not a specific page for that. And that's why they're standing behind. Well, that solves the problem automatically. Automatically. System looks at SEMrush, looks at your keywords, competitors say, well, these are a problem, you need a page for toaster, does it, prepare it, and just ask you for now, just put the picture, and in the future, that also will be automated.